Right, so this is chapter 9, section 6, dilations. And at the end of this section, you should be able to understand dilation images of figures. Actually, I'll put this in my notes. All right, so you guys, we're going to look at the scale factor of a dilation is the ratio of the length of the pre-image to the corresponding length in the image. So we're going to be looking at scale factors with the image length always in the numerator. So what we get always ends up in the numerator. All right, one of the key concepts of dilation is a dilation with center of dilation C, and that is right here, C, and scale factor N, so that's what we're multiplying by to get the new image, where N is greater than 0, can be written as D for dilation, little n to note the scale factor, and big C to note where the point of dilation, the center of dilation, is going to be. A dilation is a transformation with the following properties. The image of C is itself, so C prime is equal to C. For any other point R prime is on the ray CR, and CR prime, which is here to here, is the same as the distance from C to R times the scale factor N. Or the scale factor, and this is the important part, so let's highlight that. Make sure you put it on your... N is equal to CR prime over CR. All right, so your paper has a typo on it. Make sure you change that to CR prime over CR. And then dilations preserve angle measure. So even though your side lengths, say this, are changing, your angle measures are staying the same. So N is equal, in this scenario down here, the scale factor is equal to, let's see, CX prime over CX, which is here. So the prime always goes in the numerator. That's how I'm remembering it. All right, so let's look at this scenario and find the scale factor. We want to know if it's an enlargement or a reduction in what the scale factor is. So if I look at J prime, K prime, L prime, and M prime, it is smaller than our pre-image. This one in the black here. So I know it's going to be a reduction. So we need to find the coordinates of J, K, L, and M. So the coordinates of J are over 0 up 2. K is over 6 up 0. L is over 6 down 4. And M is over -2 down -2. See if that corresponds. And yes. So now we need to find the coordinates of our image. So the red is in pre-image. So our image J is 0, 1 is J prime. K prime is 3, comma 0. L prime is 3, comma negative 2. And M prime is -1, -1. So just by comparing these two sets of coordinates, what are we doing to each coordinate vertex to get to the next one? I can see, so we got 0, 2, and it goes to 0, 1. 6, 0 goes to 3, 0. 6, -4 goes to 3, -2. So what's the pattern? What do I multiply 2 by to get to 1? 2 times 0.5. So that's the end game. So let's ride the pony till we get to the end of the sunset. So we're going to use the distance formula because we learned up here that the scale factor is the distance of the pre-image, or the image, divided by the distance of the pre-image. So we're going to find the distance of JK. And we do that using distance formula. So it's 6 minus 0, the x's subtracted and squared, the y's subtracted and squared, and then added together. When we do that, we get 2 root 10, and I will give this to you just for fun. So 6 minus 0 squared is 36. 0 minus 2 squared is 4. 36 plus 4 is 40. 40 is also 4 times 10. 4 times 10 is the square root of 4 times the square root of 10. Square root of 4 is 2, and the square root of 10 is irrational, so it stays as square root of 10. That's how the progression goes. So let's look at J prime, K prime. We're going to do the same distance formula. So we're going to subtract the x's. So 3 minus 0 squared, and then 0 minus 1 squared gives us 9 plus 1, which is square root of 10. All right. Now we know that our scale factor n is the distance from one of our side lengths of the pre-image, which we got is root 10, and the distance of our original I can call this a pre-image. The distance of our image over the distance of our pre-image. Root 10 cancels with root 10, and we're left with what we knew from looking at the coordinates, 1/2. All right, so let's look at this problem number 2. Finding a dilation image. What are the coordinates of the vertices of D, 1/2, which means my scale factor is 1/2, of triangle PZG? PZG is this guy here. So we're going to find the center of dilation is the origin, because when they don't give you one in the problem, we just assume the origin, and the scale factor is 1/2. Because the scale factor is less than 1, we are not going to grow, we are going to reduce. It's going to be a reduction. So what we're going to do is we're going to take each of the coordinates of our figure, P, Z, and G, and we're going to multiply x and y by 1/2 to get our image. So if we look at coordinate P is at 2, 0. Two, 0. So 1/2 of 2 is 1, and 1/2 of 0 is 0. Z is at -3, 1. Half of -3 is a -1.5. And half of 1 is 1/2. And then G is at -3, or sorry, 0, -3. Ooh. G is at, oh, it's actually -2. It's like, oh, okay. And so half of 0 is 0, and half of -2 is -1. So your image, Z prime, P prime, and G prime, is going to look like this. Problem number 3, the height of a document on your computer screen is 20. So here's our computer. The document is 20.4 centimeters. And this is my suggestion when you're solving a problem, always draw the picture. When you change the zoom setting from 100% to 25%, the new image of your document is a dilation from the previous image with a scale factor of 0.25. So did it shrink or get bigger? Oh, he shrunk. 25%. Underline the correct word to complete this sentence. So because the scale factor is 0.25, which is less than 1, we had a reduction. So a scale factor of 0.25 tells us that the ratio from the image to the actual length is 0.25. So image length over actual length is 0.25. So if we took our scale factor, which is 0.25, multiplied it by the actual length, which is 20.4, we get 5.1 centimeters. So our new document is 5.1 centimeters tall.